7.6, again, out of order. This should come after lesson 7.8. Factoring by grouping is going to be part of my solution for this. All right, what do you need to know going into this lesson? One thing I want to remind everyone of is how I multiply two polynomials together. To multiply these together, our strategy was to use this box. Punnett square just organizes our multiplication for us. Put one polynomial across one side, another polynomial across the other side, multiply together. 2 times 4 is 8, x times x is x squared. 3 times 4x is 12x, negative 5 times 2x is negative 10x, negative 5 times 3 is negative 15. From your Punnett square, you can identify like terms. 12x and negative 10x is a positive 2x. So my final product is 8x squared plus 2x minus 15. So remember this Punnett square. There's an interesting pattern that has to do with this Punnett square, and that's we can always put our x squared term in the top left and our constant in the bottom right when we know we're multiplying two binomials together. So we're going to use this idea and kind of work backwards. Factoring means taking something like this and turning it into factored form. This is honestly a better way to write the function for certain purposes, specifically finding the zeros, which are often what we care most about. So factoring is going to take us from an equation, ax squared plus bx plus c. A, b, and c are just these numbers. So a would be 8, b would be 2, c would be negative 15, and turning it into a factored form. It's pretty much going to be the rest of this unit is learning how to factor everything and anything under the sun that has numbers that let us factor. So let's look at one full example and see what the steps are. All right. Our goal is to factor this polynomial. What I'm going to start with is the Punnett square. We can treat this like a number puzzle, but there's a faster, more efficient way to do it. But we're going to start from here so that we understand where things end up. All right, so this is A, this is B, and this is C. That won't matter right now, but it'll matter in a little bit. So our Punnett square, it looks like a square, but because we're not sure that the sides actually match, realistically, they won't most of the time. Let's actually call it a rectangle. Now, fun fact about a rectangle. Gonna blow your mind here a little bit. This is very clearly a rectangle, not a square. If I draw a diagonal, this triangle and this triangle from my other diagonal, that was not very, it's not very straight. Let's try and get that a little bit better. Barely better. These two triangles are the same. Okay, how do we know that? Well, the width and the height match on each side. So this triangle and this triangle share a side, the red and the blue one. The red triangle down the side and the blue triangle down the side, those sides are also the same. So the diagonals have to be equal. So it's an interesting idea. When we fill in our Punnett square, these two rectangles and these two rectangles are going to have to multiply to equal the same number. Variables and all. It's actually kind of neat how it works. So let's figure out how to use this a little bit. I will give you a much more step-by-step procedure, but I think it's important to understand where these facts come from. So remember the Punnett square we worked with. This is always going to be the x squared term, and this is always going to be the constant. All right. So our x squared term, our a term, is 4x squared in this problem. Our constant is a positive 3. And the one thing we know about these two is that they have to add up to 13x when we combine them. All right? Now, what I just talked about with the rectangle. The products have to match. So here I'm going to do 4x squared times 3. I get 12x squared. The two blue boxes, whatever this is and whatever this is, have to multiply to 12x squared. One thing we know is that they're both going to have an x. That's one thing we know for sure, is that these are both going to have an x. So we just have to look at the numbers. So here's where the number puzzle comes in. And we're going to start organizing this like a diamond, just so it gets familiar. I don't know if you've ever done these before, but if not, it's just a little way to organize our work. So the top number is the product. The bottom number is the sum. The left and right numbers are your A and your B. All right. These A's and B's aren't the same as these A's and B's. I know that might be confusing. These can be any two letters. Let's use M and N. So the sum for this problem is 13x. These two have to add up to 13x. So our diamond is going to look like 13x here. The product has to match the red one, 12x squared. We know M and N both have an x attached to them, but we need to figure out the numbers in front. All right. The way to do that is we need to find things that multiplied to 12 that will add to 13. So this is where we make a T-chart. 112, 26, 34. Those are all our options. We need to find a row that adds up to 13. It's going to be 1 and 12. So 1x and 12x. So 1x times 12x is 12x squared. 1x plus 12x is 13x. Those are going to be our two remaining boxes. Okay. So we're filling in the box. We got the box filled out. Now, we need to find a number that multiplies into both 4 and into 1. Well, the only number that multiplies up into 1 is 1. So that's easy. Now, process of elimination. 1x needs to multiply up into 4x squared with just this number over here. That needs to be a 4x. Keep going. 4x times something gets me this number over here. It's going to be 4x times 3. And then last one, 3 times something is 3. Well, 3 times 1 is 3. And that's it. These are our new parentheses. These are our factors. All right, so this is our solution. If we were to use the box to multiply, we could get back to our starting polynomial. It's a weird process, but this is more of a guess and check, understanding why it works. We're going to do this diamond a lot, but it's important to understand why we're doing this diamond. I'm going to do one more that's going to be much more step-by-step. So it's not number puzzle-y. It's going to be a lot more rigid, but I like you understanding why all of this works. Okay, much more rigid problem-solving process now. Step 1. A times C. Remember, those are our A, B, and C. So A times C, 3 times 2 equals 6. Step 2. Factors of A times C that equal B. Okay, so we're trying to look for factors that add up to -7 using the 6 we found for multiplying. Factors of 6 are 1 and 6, 2 and 3, that's it. But we need a -7. These are all positive numbers. So you have to be a little creative. A negative times a negative is also a positive. So if I make both factors negative, I'll get a +6, but now I can add up to a -7. So I'm going to go with this row. -1 plus -6 is -7. Step 3 is to rewrite the equation using the factors. What does that look like? -1 and -6 are going to make up our B term now. 3x squared minus 1x minus 6x. So these came from step 2. That's how we knew what to make the B term split up into. And then the +2 at the end. Step 3 is factor by grouping, and then we're done. Sorry, step 4. Step 4, factor by grouping. And the nice thing is, if you found a pair in step 2, your factoring by grouping in step 4 will always work. So I'm going to group things up. First one I can factor out an x, no numbers. The second one I can factor out a -2. Why'd I choose a -2? Look over here. My 3x squared was positive, and then minus 1x. On this side, I had a -6x. I wanted the first one to be positive, so to make the first one positive, I factor out a negative. So this took a little bit of thinking. So what I'm left with is x, 3x minus 1, plus -2. Divide these out, I also get 3x minus 1. We expect to get those to match. Then we factor out the common parentheses, and we get our solution. So I'm going to rewrite this all the way up here. 3x minus 1, x minus 2. So there's 2 ways to do this, and we're going to explore doing them every way under the sun in class. I honestly think doing it like a number puzzle is a little more fun, but this is a very rigid step-by-step that will always work for you. The only place where you have to do any thinking and guessing and checking really is in your factor table, and that's hardly even guessing and checking. So we're going to practice both methods in class. I think the number puzzle version is more fun, but for those of you who really like a process that you can trust and always works, this will get you there.